Greetings everyone. So today we are going to discuss and learn about the question that is related to the parametric equation and a conic section. So let's go through to the first question. We are given a curve that is defined parametrically by x equal to 9t square minus 1 over 3t and y equal to 9t square plus 9t plus 1 over 3t, which is the t is not equal to 0. So the first question is it asks to find the coordinates of the point where the tangent line to the curve is parallel to the x-axis. So from this question we already know that when it is parallel to the x-axis, meaning that the dy dx will be equal to 0. So to solve this question we need to apply a chain rule, which is the dy dx equal to dy over dt dot dt over dx. So in this chain rule we have to find the dy over dt and the dt over dx. So to find the dy over dt we have to differentiate our y, which is this one. So when we differentiate it, we will get the derivative by using the quotient rule. So the quotient rule we apply to the y, and finally we will get the dy over dt, which is the 9t square minus 1 over 3t square. Same method we apply to the x, which is this one, we using the quotient rule. So when we solve, we will get the derivative of x, which is the 9t square plus 1 over 3t square. After we get the value of dx over dt and dy over dt, we can substitute into our chain rule, which is the dy over dt over dx over dt. When we substitute the value, we can directly cancel out the 3t square, and finally we will get 9t square minus 1 over 9t square plus 1 equal to 0. We solve for the t, and finally we got the two value of t, which is the plus 1 over 3 and negative 1 over 3. Since it asks to find the coordinates, so we have to substitute our t value into our x and y equation. So when we substitute the 1 over 3 into x and y equation, from the equation we will get two answers, which is x equal to 0 and y equal to 5. And when we substitute the negative 1 over 3 into our x and y, we will get x equal to 0 and y equal to 1. So we can conclude that the coordinates of the point where the tangent line is parallel to the x-axis are 0, 5 and 0, 3, 0, 1. So that is how we solve the question number 1a.
Sir, we have a question.
Excuse me, sir. For question 1a, if the question asks how to find the coordinates of the points where the tangent line to the curve is perpendicular to the x-axis, is the dy per dx equal to 0?
Alright, thank you for asking a question. So when the question states that find the coordinates when the curve is perpendicular to the x-axis, we can simply say that the dy dx is not equal to 0, meaning that we can say that it is undefined. But in our question, it said that it is parallel, so we can just let the dy over dx equal to 0. Okay, now we proceed to the question 1b. The question asks, is there any tangent line to the curve which is parallel to the y-axis? And justify your answer. So from the question 1a before, we already know that the dy over dt is equal to 9t square minus 1 over 3t square. And since we know that it is parallel, so we can let the dx over dt equal to 0. And we solve for our t, and finally we get the t square equal to negative 1 over 9. But the t square must be equal or greater than 0. And when we solve this question, we have the t which is the negative 1 over 9, which is it has no real solution. So since has no real solution for any real value of t, we can conclude that there is no tangent line to the curve that is parallel to the y-axis.